Hi guys, my name is Mima. I live in Fairy Meadow, Wollongong. From my place, you can see the tippity top of Mount Kira. I've been on a few hikes through that mountain, and I've gotta say, it's beautiful and also chock full of plants. But I also wonder, are the plants growing on the bottom of the mountain any different than the ones on the top? I read some papers that look into this very question, and it seems like the answer is yes. Turns out that higher phenotypic plasticity is correlated with how much a plant can take advantage of its different habitats, and there's even some functional traits in plants that change depending on the altitude. So the real question now is, what is the extent to which phenotypic plasticity allows plants to express advantageous traits at different elevations? In simpler words, how well can plants adapt to live in different elevations? So, how is it that I can fill out a bit of this knowledge gap? Well, I've got a good location to do the study, but what plant would be a good contender for a study like this? Okay, so according to INAT, these are the most common plants found on Mount Kira. And let's see. Oh, yeah, I've seen this one a lot on my hikes, and it looks like there's a lot of them all over Mount Kira. That's perfect, because I'm going to have to compare the same plant in different elevations. Okay, location, check. Study subject, also check. So how do I design the actual study? If I wanted to study how plants differ by elevation, I could survey multiple plants within the same elevation. Mount Kira spans about 39 meters above sea level to 464 meters above sea level. So let's divide the elevations into 5 different bands, like this. Okay, it's starting to flesh out a bit. How is it that I should survey the plants, though? Transects will be good, but even better is a thick transect. I chose to do transects that are 10 meters by 20 meters in size, basically a long rectangle. And then, so that the plants I survey in the transects are random, I used a random number generator. The first number determines how far along the length of the transect the plant is, and the second number is the distance from the middle of the transect. I'll do 3 transects for each band of elevation, and I'll also survey 6 plants in each transect. With a bit of maths, that'll be a total of 90 plants surveyed. I'll count the number of flowers and fruit on each plant, measure the height, and take 3 leaves for my leaf area analysis. Oh. What the Oh my god, that's an echidna. Oh my god, Sonic the Hedgehog. So, what is it that I expect will come out of this investigation? My hypothesis is that the Solanum pseudocapsicum will show a phenotypical difference in its physiology between the different elevations. If this hypothesis is true, then that means it's really likely that these plants differ phenotypically to be able to adapt themselves better to different habitats. Could it also be genetic? It may very well be, but that's all for the discussion section for this assignment. Okay, bye!